Hey everyone, and welcome to the Foundry by Forge College. I'm your host, and we are jumping right into our explainer on Cloudbreak's advantages today. So, if you recall from our last lesson, the one on performance and cost considerations for Cloudbreak's data structure, we saw how partition layouts directly affect latency and throughput, right? Well, today we're zooming all the way in. We're going to uncover exactly why Cloudbreak is an absolute game changer for Solana's state storage and how it literally makes everything run so much smoother. Okay, let's dive right in. Here's a quick look at our blueprint for today. We'll start with the monolithic problem, then enter Cloudbreak slices, move on to unlocking parallel reads, look at an order book application, discuss the metadata trade-off, and wrap up with some next steps. Section 1, the monolithic account problem and the single blob bottleneck. Okay, to really understand why the old way of organizing on-chain state caused such massive scalability bottlenecks, I want you to think of the traditional single blob layout like an encyclopedia. Imagine your poor CPU having to lug this massive heavy encyclopedia off a shelf, open it up, and read through hundreds of dense pages, just to find one tiny detail. That's exactly what deserializing a full account blob feels like. It is absolutely exhausting for the processor. Now compare that to the Cloudbreak style layout. This is way more like just handing your CPU a perfectly placed sticky note. You just map and grab the exact field region you need. No heavy lifting required. Moving on to Section 2, enter Cloudbreak memory slices and optimize memory layout. So this is our ingenious new blueprint. We're basically stopping this habit of treating storage like a giant messy box, and instead we start treating it like neatly organized rows and columns. When your program asks for data, the runtime doesn't do that heavy chore of copying the entire account blob anymore. Instead, it just points to a contiguous subset of data and returns a reference. By keeping related fields physically close together, it preserves what we call cache locality. It saves memory, it saves CPU cycles, and honestly, it makes everything incredibly efficient. Now, the really crucial part is how this executes under the hood. Let's walk through this conceptual Rust-style snippet. Step 1. The runtime locates the offsets table, which is basically just a handy little index map. Step 2. It maps the requested field name to its exact byte offset and length. And finally, Step 3. It just returns a safe, immutable slice referencing only those specific bytes. The runtime completely skips heavy allocations just by pointing directly to the bytes we actually need. Section 3. Unlocking parallel read concurrency and finer-grained concurrency. Disjoint slices mean no global lock contention. What does that mean? Well, in the older monolithic models, it was kind of like being in a massive supermarket that literally only has one checkout line open. Even if you were just buying a single pack of gum, you were forced into the exact same coarse-grained lock, stuck waiting behind someone with 3 overflowing carts. Cloudbreak completely changes the game here. By using disjoint slices, independent readers can access what they need simultaneously. It essentially opens up a checkout line for every single aisle. This means independent readers can grab data at the exact same time without stalling the pipeline at all. Let's look at Section 4, real-world order book apps and high-read scenarios. Let's ground these abstract systems-level concepts by applying them to the heavy demands of a decentralized exchange. Imagine this scenario. You've got a massive influx of clients, and they are all frantically pulling your Solana program for just the top-of-the-book price, multiple times a second. In a single blob layout, every single one of those requests forces the system to deserialize the entire price level array. It's absolute chaotic CPU thrashing. The cache is missed because hot data is just mixed in with cold data, and clients experience huge latency spikes, all just to get a few tiny bytes of pricing info. But look at the cascading benefits of Cloudbreak in this exact same scenario. That top-of-book data is kept in contiguous small slices. When those hundreds of requests hit, they're satisfied straight from a cached page. There is zero heap allocation on the read path. And because of those immutable slice references we talked about, they're served completely in parallel. Cloudbreak easily absorbs that massive client load without breaking a sweat, which leads to a much more graceful degradation curve under heavy demand. Section 5. The metadata trade-off and layout complexity. Because let's be real for a second, every solid engineering blueprint comes with some trade-offs, right? A single blob layout is cheap on metadata overhead, sure, but it is terrible on read costs and concurrency. Cloudbreak, on the other hand, does ask for a bit more upfront. You have a higher indexing metadata overhead, but in exchange, we achieve blazing fast amortized read paths, parallel concurrency, and extremely high cache friendliness. We accept that upfront cost because the read path becomes the dominating factor, making it just an incredible trade-off for read-heavy programs. Section 6. Key takeaways and next steps. Okay, let's wrap up our little architectural tour here. The crucial point really boils down to three main principles you need to remember when you're designing your account schemas. First, slice locality reduces your per-read work. Just remember the sticky note instead of the heavy encyclopedia. Second, concurrency granularity avoids serialization. Everyone gets their own checkout line, so there's no waiting. And third, metadata amortization highly favors predictable hot paths. Make sure you keep these tightly in mind. To finish up, I want to leave you with this slightly provocative thought. Which fields in your Solana application are hot, and how many concurrent readers do you really expect? Mapping this out is going to prepare you perfectly for our next lesson, which is all about evaluating performance metrics for Cloudbreak. Thank you so much for joining me for this explainer. I highly encourage you to keep learning and check out more courses over at forge.college to dive deeper into this subject and, of course, other incredible Web3 topics. Keep building, and I will see you in the next one.